I'm kind of taking that same scenario. I'm taking that same, let's see. I'm taking that same situation. Okay, participants. Zoe. Okay. Good morning, Zoe.
Good morning.
Okay, so what we're getting ready to do is we're going to get ready and start taking notes on our new section. And so go ahead and get out a sheet of paper. We're going to be in lesson 90 in the textbook on page 197. Okay, so go ahead and open to page 197, lesson 90. For some reason. See if that'll work with the air, because it kind of felt like the heat was on. Alrighty, so we started talking a little bit the other day about quadratic equations. Okay, so the first thing I want to do is go ahead and start with our notes. And quadratic equations, and this is going to cover lessons 90 through 95. Okay, so these notes are going to be something that you're going to need to hang on to for all of these sections because we're going to be adding to them. Okay, so on page 197, we learned that a quadratic equation, we said is a 4-term polynomial to the second degree. Okay, a 4-term polynomial to the second degree in the form of ax squared plus bx plus c equals 0. So this gives us our 4 terms. Bless you. And then when I say second degree, bless you.
Thank you.
Second degree means that I cannot, or first of all, let me say that one thing. We'll go ahead and put our rules here. A must be greater than 0. You must have a term with an exponent of 2, but not greater than 2. Okay, so like we talked about, my four terms, ax squared plus bx plus c equals 0. Yes. A must be greater than 0. I have to have a term that has an exponent of 2, or a variable with an exponent of 2, but it cannot be greater than 2. Okay? So each time you're looking to assess, do I have a quadratic equation? I'm looking for four terms. A is greater than 0. I have a variable with an exponent of 2, but not greater than 2. Now, one of the things we did mention when we were looking at lesson 90, we kind of started working with some of these when it was asking, is this a quadratic equation or not? Okay. And remember that we said if we have let's say x squared plus 3x equals 0. Then what do we know? What do we know that my number is for C here? 0. C equals 0. So x squared plus 3x plus 0 equals 0. And this is a quadratic equation. Because remember, our only rule is that A has to be greater than 0. B can be 0, and that means it would cancel out the B term. C can be 0, and it can cancel out the C term. So I know that as long as I have x squared equals 0, then I could plug in 0 for my B term and 0 for my C term and still have a quadratic. Okay? If I had x squared plus 3 equals 0. What term am I missing? Am I missing B or C in this one? I'm missing my B term, right? So then that means B is equal to 0. So I'd have x squared plus 0x plus 3 equals 0, and that is a quadratic equation. Because B was 0, 0 times x is 0, so it's just not written there. Okay? So I can write it with my 0x in there, and now it's a quadratic. What if I have x squared equals 0? If I just have this, then I could have x squared plus 0x plus 0 equals 0. Okay? So one of the things that I always need to do is to remember that even though a quadratic equation that has to have four terms, I don't want to automatically jump and go, oop, not a quadratic equation. Well, yeah, it could be, because here my C term is 0. I only have 3 terms. Nope, it's not a quadratic equation. Well, it could be, because B is 0. Okay, so I've got to look at it and think through. All right, now I could not have 3x equals 0. Why? I don't have an A term. Okay, bless you. This is basically bx equals 0. Now C could be 0, but remember A can't be 0, so it cannot be gone. I would have to have an exponent to the second power, and this would have to be the A term, and it has to be greater than 0. Okay, so I think we looked at a couple of these examples in the bottom of page 197. So let's go ahead and look at the bottom of 197, activities 2. I think we did the first 3 across the top. Let's look at the next row of 3. 2 sets of parentheses here. I have x minus 2 times x plus 6 equals 0. What do I know I need to do to 2 binomials in parentheses to determine if it's going to be a quadratic? Multiply. I'm using FOIL. Good. So go ahead and FOIL the first one in the second row. I'm going to erase these over here so I have room to work. So remember, one of the things that anytime you see 2 binomials to multiplication, you need to think FOIL. Okay? So this is x minus 2 times x plus 6 equals 0. Bless you. Okay, so when you FOIL it, x times x is x squared. X times positive 6 is 6x. Negative 2 times x is negative 2x. And negative 2 times positive 6 is negative 12. When I combine my middle terms, I have a positive 6 and a negative 2. Take the sign of the larger, so it's going to be positive. And 6 minus 2 is 4. So I end up with x squared plus 4x minus 12 is 0. Is this a quadratic equation? Yeah. A is greater than 0. I have an exponent to the second power, and I have 4 terms. So yes, it is a quadratic equation. Let's look at the next one. What would I have to do to the next one? FOIL it. And what do I know immediately when I multiply first terms?
It's not a quadratic equation.
Okay, so look at this one. I've got x squared minus 3 times 2x plus 5 equals 0. If I were to FOIL this one, x squared times 2x is going to give me 2x cubed. Right there, I've got a red flag going, okay? And so again, I can go ahead and keep going. 5x squared, negative 3 times 2 would be negative 6x. And then negative 3 times positive 5 would be minus 15. So when I write this one out, I've got 2x cubed plus 5x squared minus 6x minus 15 equals 0. How many terms do I have now? 5 total, because remember, so I've got 1, 2, 3, 4, 5 terms, and I have an exponent of 3. So I know this is not a quadratic equation. There are 2 things that make this one not a quadratic equation. I have an exponent higher than 2, and I have 5 terms total. Okay. Let's look at the next one. 2x plus 5 times 2x minus 5 equals 0. Let's go ahead and FOIL it. 2x times 2x is 4x squared. 2x times negative 5 would be negative 10x. 5 times 2x is positive 10x. And 5 times negative 5 is negative 25. When I combine negative 10x and positive 10x, what do I have? 0. So what does that mean the value of b is? So basically, this is like saying 4x squared plus 0x minus 25 equals 0. This middle term here is right there, represented with a 0. So now I can see 1, 2, 3, 4 terms. A is greater than 0. I have an exponent of 2. Quadratic equation or not? Yes. Good. Okay, I'm going to erase these notes over here so far. I'll leave this heading part. All right, let's look at the bottom row. 3x minus 1 times x squared plus 4. Did I skip one?
Skipped a row.
Oh, my bad. I sure did. All right. I was thinking there were only 3 rows total. Okay. I've got 2 times x squared plus 5x equals 0. What am I going to do here? Distribute. Good. Anytime I see a number outside of parentheses, I know I need to distribute that. Okay. So I'm going to distribute the 2 to each term inside parentheses. So I'm going to have 2x squared plus 10x equals 0. What is missing? The c term. So what does that mean it would be? 0. So I'd have 2x squared plus 10x plus 0 equals 0. So remember, if I'm missing B or C, I can assume that they're 0. I can plug it in as a 0 and see that I do have 4 terms. A is greater than 0. I have an exponent of 2, so it is a quadratic. Okay. X plus 3 times x minus 3. If we look at this one down here and we see where I had the same terms plus and same terms minus, what can we assume is going to happen to the middle terms? They're going to cancel out and be 0. I'm going to have the same situation here. That's a pattern that I can see every time I multiply same terms plus, same terms minus. Those middle terms cancel out. So I'm going to have x squared minus 9 equals 0. But that means I've got x squared plus 0x minus 9 equals 0. Quadratic equation? Yes. All right, the last one in that row. X squared minus 4 times negative x squared plus 4 equals 0. Let's FOIL it. What's x squared times negative x squared?
Negative x to the 4.
Good. Negative x to the 4th, and then x squared times 4 will be positive 4x squared. Negative 4 times negative x squared. Negative times a negative is a positive. So again, I have 4x squared, and negative 4 times positive 4 is negative 16. These are the same terms in the middle. So I have negative x to the 4th plus 8x squared minus 16 equals 0. How many terms do I have?
4.
I have 4 terms, so I'm good there. Is A greater than 0? How do I know A is not greater than 0?
No,
Because it's negative, and on the number line, when I think about positives and negatives, and I think about 0, negatives are to the left, and so I know that it is less than. So I know that that negative messes me up, and so does that exponent to the 4th, so it is not a quadratic. All right, let's look at the last one, last row, finally. All right, so now 3x minus 1 times x squared plus 4 equals 0. Let's see if the marker's over here a little bit darker. All right, let's start by FOILing. That's much better. 3x times x squared, 3x cubed, 3x times 4, 12x, negative 1 times x squared will be negative x squared, negative 1 times 4, negative 4, 3x cubed. Now, if I'm putting these in order, what would come after 3x cubed? Negative x squared. Remember, when I'm writing my answer in order, I want to go in descending order of exponents. So I go alphabetical order of variables and descending exponential order. So 3x cubed would come first, then I'll have minus x squared plus 12x minus 4 equals 0. How many terms do I have?
5.
5 terms. I know it's out. What else makes it out?
Exponent greater than 2.
I have an exponent greater than 2. So this is not a quadratic.
Which one on the last row is this?
I'm sorry?
Which one on the last row is this? I can't really tell because
That's the first one. That's the 3x minus 1 times x squared plus 4 equals 0. First one, last row. All right, then the one below that, 3x plus 4 times 2x plus 1 equals 0. FOIL it. 3x times 2x, 6x squared, 3x times 1, 3x, 4 times 2x, 8x, and 4 times 1 is 4. 3x and 8x is 11x, so I have 6x squared plus 11x plus 4 equals 0. How many terms?
4.
4. Is a greater than 0? Yes. Do I have an exponent of 2?
Yeah.
Do I have an exponent greater than 2?
No.
Is it a quadratic equation? Okay. And then the last one, 4 times x squared plus 3x plus 2 equals 0. I'm going to distribute 4x squared plus 12x plus 8 equals 0. How many terms? 4. Is a greater than 0? Do I have an exponent of 2? Do I have an exponent greater than 2? Awesome. Is it a quadratic? Okay. So do you see how each time we just went through those rules that we said, hey, for it to be a quadratic equation, 4 terms, a is greater than 0, I have an exponent of 2, I do not have an exponent greater than 2. So I was asking myself those same questions every single time to assess whether or not I have a quadratic equation. Okay. So now let's go ahead and turn over to lesson 91. That is on page 201. Lesson 91, page 201. All righty, so I'm gonna go ahead and make a note right here. This is lesson 91, page 201. And it says each quadratic equation has 2 solutions. So quadratic equations have 2 solutions called quadratic equations have 2 solutions called
Roots or zeros?
roots or zeros. Roots or zeros. That's the second sentence. The solutions of a quadratic equation are also called roots or zeros. So it says the terms solution, root, and zero may be used interchangeably when discussing equations. So if you see directions and it says to solve and state the roots, or solve and state the zeros, or solve and state the solutions, it's all talking about the same thing. Okay? To solve a quadratic equation, I'm going to find 2 solutions. Doesn't matter if I call it a solution, a root, or a zero. In a minute, you're going to see why it's called a zero. Okay. So it says the number of solutions is equal to the value of the highest exponent. So that is why I have 2 solutions, because my highest exponent is 2. Okay. So understanding that my exponent of 2 tells me I will have 2 solutions. Okay. And it says there are 3 different methods of finding the roots of a quadratic equation. So 3 methods to solving for roots of quadratic equations. Three methods to solving for roots of quadratic equations. Now, the first method is going to be factoring, because that is y'all's favorite. Why do I hear laughs? All right, so this is going to be, we're going to deal with factoring in lessons 91 and lesson 92. So you can put that in parentheses. We're going to be looking at factoring using lessons 91 and 92. Okay, my second method is going to be completing the square. Completing the square. And right now you have no clue what that is, and that is just fine because we're going to learn about that in lesson 93. Completing the square will be lesson 93. And then our third way will be using the quadratic formula, which will be in lesson 94. Using the quadratic formula, and we'll do that in lesson 94. Okay, so we're going to be looking at 3 methods to solving for roots, solving for zeros, solving for the solutions, factoring, completing the square, and using the quadratic formula. Okay, so we're going to start off in lesson 91, working with solving using factoring. And you can see that in our book, they have bullet points for us. Okay, so we know steps in a process. We've talked about this all year long, that everything we do in algebra is going to be steps in a process. Everything we do in math is going to be steps in a process. So if I learn that process, then I can plug in and I can use any problem that I've got and find the answer because I know the steps in process. Okay, so our next note will be solving for roots by factoring. Okay, so what you're going to do is each time you have to solve a quadratic equation, you're always going to start and say, can I factor it? That's usually going to be one of the first things that you look at and say, hey, is this equation factorable? Because sometimes we may run into an equation that is not factorable and I have to use a different method. Okay, we'll talk about that. But right now, I want to look and see, is it something that can be solved by factoring? So step 1 is I want to set the equation equal to 0. So my first step is to set the equation equal to 0. I want to make sure that I have ax squared plus bx plus c equals 0. My second step is to factor the polynomial. This is where I set up my 2 sets of parentheses. I look and say, okay, what is going to be my first term? I look to see what are my signs going to be. Are they going to be the same? Are they going to be opposites? And then I look at my last term and I say, hey, I need factors of this number that add together to equal my middle number. Now, sometimes it may just be a simple factoring. Sometimes I may have to whip out my box method, okay? Usually, you know that you're going to need to use box method if that first term is greater than 1. If I have a number in front of a other than 1, if I have 2, 3, or above, then I know that I'm going to have to use box method to make it a little more easy, okay? And then at step 3, this is where we take it a little bit further from when we just factored. We had a polynomial, we factored. Now we're going to take each factor equal to 0. So I'm going to put set each binomial equal to 0. And then 4, solve each binomial. So let's take a look at what that looks like. The example they've given me is x squared plus 5x plus 6 equals 0. Okay, so I look at this and I say, hey, I've got a quadratic equation. I know I can factor this trinomial because I can look at this and say, hey, I know that I would have 2 sets of parentheses. What is my first term going to be? X. What do I know my signs are going to be? Both positive. This one tells me they will be the same. This will tell me they will both be positive. Now, I need factors of 6 that add together to make 5. What are my factors of 6 that add together to make 5? But remember, they're both positive, so I can't have a negative. 2 and 3. X plus 2, x plus 3, Now remember, I'm setting equal to 0. The main thing that's going to be so different here is I've got to remember to set all of this equal to 0. Okay? So now step 3, set each binomial equal to 0. What I'm going to do is I'm going to say x plus 2 equals 0 and x plus 3 equals 0. So do you see step 3? I'm taking each parentheses, putting it equal to 0. Okay? And now I solve for x. So what is x going to equal here? Subtract 2 from each side. So what does x equal? -2. What am I going to do here? Subtract 3 from each side. So what does x equal? So in this answer, x is equal to -2, x is equal to -3. I've solved each binomial. Remember, we said that each one's going to have 2 solutions because I have an exponent of 2. These are my 2 solutions. Okay? Set it equal to 0. Factor. Set each binomial equal to 0 and solve. And there are my solutions. Okay? Let's go ahead and take a look at our classwork. I'm going to erase this example here and we'll do classwork right here. So in their classwork, my first one is x squared plus 6x plus 8 equals 0. Okay, so step 1, we've set it equal to 0. What do I need to do next? What is step 2? Factor. So I'm going to set up my 2 sets of parentheses. I'm going to go ahead and set it equal to 0 so I don't forget that. So I have my parentheses equal to 0. What will be in my first term in each set of parentheses? X. What are my signs going to be? Positive. Both are positive because this one tells me they're the same. This one tells me they'll both be positive. Now I need factors of 8 that add together to make 6. 4 and 2. Good. All right. So now I have factored. What's my next step?
Put them in the x plus 4 equals 0.
Set them both equal to 0. Good. X plus 4 equals 0 and x plus 2 equals 0. What is x going to equal here? -4. X equals -4. What's x going to equal here? X equals -2. So there are my 2 answers. Challenging stuff, huh? See, it's not so big of a deal. I say, hey, we're going to solve quadratic equations, and everyone goes, whoa, I can't do that. Yes, you can. Okay? We can factor. We've learned how to factor. We can do this. Okay? Now all we've done is we have added the extra step of, okay, so each factor, I'm just setting it equal to 0 and solving. We kind of did that with our rational expressions because remember when we had to solve, we had to state exclusions? That's exactly what we did here is we said, what can x not equal? Well, this time we're saying x does equal it, okay? So it's kind of similar to what we've done with factoring and with rational expressions. We're kind of putting it together, but it's a little bit different with quadratics, okay? Let's look at the one below it. X squared plus 2x minus 3 equals 0. Set up parentheses, equal to 0. What will my first terms be? X. What are my signs going to be? Opposites. Opposite signs, the larger will be positive. So I'm going to put plus, minus. Factors of 3 that will add to, or factors of -3 that add together to make +2. -1, +3. Good. Okay. So now I'm going to have x plus 3 equals 0 and x minus 1 equals 0. What is x going to equal here? Remember we just said the opposite of the same number, right? So what is x going to equal here?
1.
Opposite of -1 is +1. There are my solutions. Okay, let's look at the next two. I'm going to have x squared minus 7x plus 10 equals 0. Set up our parentheses. What's my first term going to be? X. What are my signs going to be?
Both negative.
Both negative. This one tells me they are the same. This one tells me they're both negative. All right. Factors of 10 that add together to make -7. 5 and 2. So -5 and -2. So x minus 5 equals 0. X minus 2 equals 0. What does x equal here? +5, good. X equals 2. There are my solutions. And let's look at the next one. X squared plus 6x equals -5. They've thrown us a little curveball here. What did they do differently this time?
There's only plus 0.
Okay, so I only have 3 terms here. I have a -5 on the right-hand side instead of 0. What is step 1?
Set the equation to 0.
How can I set this equation equal to 0? Sadie?
2 plus 5.
I'm going to add 5 to both sides because I need to make my right-hand side 0. So if I add 5, I have x squared plus 6x plus 5 now equals 0. So if you do not start out with equals to 0, then I need to make it equal 0. Okay, so that's first step is set the equation equal to 0. So in this one, I had a -5 on the right-hand side. I needed to move it to the left-hand side. To move a negative, I add it. So I have to add to both sides. Now my right-hand side equals 0. Okay, so we did step 1. Step 2, set up our parentheses. Equals to 0. What will my first term be? X. What are my signs going to be? Both positive. What are my numbers? 5 and 1, 1 and 5. So I have x plus 5 equals 0. X plus 1 equals 0. So x equals
-5.
or x equals.
-1.
Okay. Now, one of the things I want to tell you is you can leave them separated like this, or if you wanted to combine them, you can have x equals -4, comma, -2. X equals -3 and 1. If you want to combine it into a single x statement, you just put commas between them. Okay? So it's totally up to you what you want to do. Now, notice I'm just going to put them in order. X equals -1, -5. Okay, so you can either leave them separate or you can put them together as one statement. It's totally up to you. All right, I want you to go ahead and start working on activities 2 on page 201. In your book, at the bottom of the page, follow your steps in a process.
can't see.
Okay, it's almost time for the bell for the break, but we'll go ahead and start looking at number one. What do I need to do with number one?
Turn it into factor it.
Factor it, set it equal to 0. So I'm going to have x. We'll finish when we come back. You doing okay, Zoe?
Doing okay. It's just like the reason why I'm not here is because I threw up last night.
Oh, I'm so sorry you're feeling bad.
It happened to my brother because he went to his friend's house. He got
Yeah.
a
Yeah. Okay.
situation beside.
You following along okay, though?
You know, it's off and on.
Okay. All right. Well, be sure to let me know if you have any questions or if we need to set up a separate Zoom for tomorrow or something, let me know and we'll try to work out a time. But okay.
Because I have a lot of people around me.
Yeah, because I know it's hard.
Thank you.
You're welcome. I hope you're feeling better. Everybody good?
Is everything okay?
Yeah, somebody dropped a book outside.
I thought I heard a gunshot.
No, I know I was going to say they just dropped a book, but it was like more of a slammed it on the ground, I think.
Tell me you guys are okay or text them. I probably
Yes, all is well.
Okay, that's good.
And so I just wrote on the top corner of the board, the homework assignment that'll be for this page or for this lesson will be page 202, activities 3. On paper, and I'll be checking it for an effort grade on Thursday. Is that our only homework? Probably. Chad, you coming to see me at lunch? Awesome. So as soon as I finish up in here, I clean up, wipe tables, and I just go right next door to that room. Okay, so when we change, we'll go over there.
I like how I barely tapped you over there, and then you're like, ow, and then you just started to kick me. Oh, you just ran off.
Alrighty, so we were getting ready. We're getting started on this one. You will notice that I went ahead and made a note up in the border, the corner of the board, the board corner. Homework will be page 202, activities 3, on paper, due Thursday. I will be taking it for a grade. Okay. The initial grade will be an effort grade. Then I will take it up to grade for accuracy. So on Thursday, I'm taking up page 202, activities 3 on paper. Okay. 202, activities 3 on paper. Alrighty, so let's go ahead and take a look. We said that our first terms are going to be X. What are my signs going to be?
Positive.
Both positive. And what are my factors going to be?
6 and 3.
6 and 3. Good. So we know that X equals, Oh,
negative.
actually, so let's go ahead and do this. Because, or X equals -3. Because in that sense, I'm actually, if you setting this step equal to 0, if you don't want to write it out and you're doing it mentally, that's okay too. Okay, that's as we continue to go on. Okay. So this is actually a step that you can do in your head. Okay, as long as you have your factors written out, then you can go ahead and look at it immediately and say, hey, X is equal to -6, X is equal to -3. So there are your answers. Okay, what am I going to do for the next one? Set up my factors equal to 0. First term is X, X. My signs are going to be opposites. One will be a plus, one will be a minus. Which will the larger be?
7.
Oh,
Sorry.
okay. So 7, and it'll be positive. And then -2. So what does X equal here?
-7.
-7, and here X equals 2. Good. Right. Set up binomials equal to 0. X plus or minus, opposites,
They're both negative.
both negative. Factors of 36, factors that add together to make -13.
4 and 9.
4 and 9. So X equals 4 or X equals 9. Now, what do we have to do to number 4 first?
Add 20.
I need to add 20 to each side before I can get started here. Okay, because I've got to solve for 0. So I'm going to have x squared minus 9x. What's my next? Plus 20 equals 0. It was -20 over here. To move it from the right to the left, I have to add it. That is why it's positive over here. So now I'm going to set up my binomials. I'll have x and x. Signs are
Both negative.
same, both negative. And what are my numbers?
5 and 4.
5 and 4. So x equals
5,
5 and x equals
4.
4. How'd you do? Everybody do okay on that? Awesome. So notice homework, page 202, activities 3, on paper, due Thursday. I will be looking at it at the very beginning of class, looking at number 1, you showed your work. Okay, you can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 problems. So I will be looking for 12 problems. Show your work with answers. Okay, so I'm just going to come by and scan. Did you make, and it's going to be an all or nothing. You either got a 10 or a 0. Okay, you either have all 12 done or you get a 0. All right, everybody go with me? You either got a 10, so you're either making 100 or a 0, no in between. Then I will take it up for an accuracy grade. So what that means is as we go over it in class, if you've made a mistake, you should correct it on your paper. And then when you hand it in at the end of class and I take it up, you should make 100 on that one as well. Okay, so I'm trying to give y'all a couple of hundreds on your homework grade. So let me give them to you. Okay, let me give you hundreds. All you got to do is do the work. So
How should we number them?
okay, so if you want to number them, you can just go from side to side. 1, 2, 3, 4 across the top, 5, 6, 7, 8 in the middle, 9, 10, 11, 12 across the bottom. Okay. 1, 2, 3, 4 across the top, 5, 6, 7, 8 in the middle, 9, 10, 11, 12 across the bottom. All right, so all you're going to be doing is factoring just like we've just done. Factor, solve for each binomial. Okay. Now, I will tell you that if you look at the very last one, look at number 12 in that homework. I do not know why they put this example in this because it actually goes along with lesson 92. So we're getting ready to do lesson 92, so you will know how to do number 12. Okay, but they did it. Okay, so I'm going to go ahead and erase these notes, and we're going to start with notes for lesson 92.
Couldn't you just substitute it with zeros?
Man. Now notice that this section is called solving by taking roots, but remember these look like, remember these were some of our special, oh my goodness, I lost the word.
Special Jesus.
Not special Jesus, no. Factoring.
Special equations.
The difference of two squares. Why would I say it? Okay. So factoring, I guess they call them special products. That's what it was. So back in lesson 69, where we factored, so lesson 69, page 151, we were factoring the difference of two squares. So now this is very similar to where I'm factoring the difference of two squares, but they're calling it taking roots here. Okay. So lesson 92. This is going to be factoring by taking roots. Okay. So it says, so far you have learned to solve quadratic equations by factoring. In this lesson, you will learn a shortcut that works for certain quadratic equations. Okay. And these certain quadratic equations are called the difference of two squares. Factoring by taking roots of the difference of two squares. Okay, so it says anytime that A equals 1, B equals 0, and C is less than 0 in a quadratic equation, leaving you with the format x squared plus C equals 0. You can take the roots to find the solution. Okay, so one of the things that I want to show you first is like we did a minute ago. Okay, so a minute ago, if we had, let's look at the examples they've given us. X squared equals 4. So from lesson 1, if we were following that method, we would say, okay, I have x squared minus 4 equals 0. right? But notice if I've got x squared, oh, no. So basically this is x squared plus 0x minus 4 equals 0, right? But notice that, what does this tell me? I'm going to have opposite terms, right? So I'd have two sets of parentheses, and I'd have x and x. I know I'm going to have a plus and a minus. And I need terms that multiply together to make 4, that when they're added, to make negative 4, that when they're added together, they make 0. So that means they're going to have to be the same terms, right? Because they're going to cancel each other out if I have a 0 in the middle. So what would those two terms be? 2, because x plus 2 and x minus 2. Is everybody good with that? Because remember, if I FOIL and I have x squared, x times x is x squared, then I have x times negative 2 is negative 2x, and 2 times x is positive 2x. That negative 2x, positive 2x cancels each other out. So that's that 0 there, okay? So then here I can see that x is going to equal negative 2, or x equals positive 2, okay? This is doing the same method that we just learned, but in this lesson it says, hey, but there's a shortcut. I don't know about you guys, but I'm always looking for a shortcut, okay? I'm always going, what's the least I can do to get by? I know none of y'all are like that. I know all of y'all like to go step by step and write out everything. Okay, so this was following the pattern, or following steps for lesson 91. Now, in lesson 92, they give us shortcut steps. Okay? So the first thing it says is step 1 is to isolate the x squared term. Now remember, isolate means get it by itself. Okay? I want to isolate the x squared term. Step 2 is I'm going to take the square root of each side. Take the square root of each side. Step 3, state the two solutions. I'm going to put in parentheses, numbers will be the same, but one is positive and one is negative. So step 1, isolate the x squared term. Step 2, take the square root of each side. Step 3, state your answers. They're going to be the same number. One's positive, one's negative, and I'll show you another way to write those answers. All right. So this was the example they gave us. X squared. Actually, I guess they started out with x squared minus 4. So if I have x squared minus 4 equals 0. Step 1 tells me I need to do what?
Isolate.
Isolate the x squared term. What is with x squared over here? Negative 4. How am I going to get that negative 4 away from x squared? Add it. So now I have x squared equals 4. Okay? I've isolated x squared on one side. I have my number on the other side. What does step 2 tell me I need to do? Take the square root of x squared. Take the square root of 4. What is the square root of x squared? X. What is the square root of 4? 2. Now, when I state my solution, I want to write this as a positive and a negative. Because look at this right here. If I'm looking at the square root of 4, that could mean that I've got 2 times 2, or I could have negative 2 times negative 2. Because what is 2 times 2? Positive 4, right? What is negative 2 times negative 2? Positive 4. So when I have a positive 4 here, I don't know if my square root is a positive or a negative. I don't know if they're going to be positive or negative, so I have to state my answer as both possibilities. And this is my shortcut way of writing it. Plus or minus 2. I can write it all in one statement, and there's my answer. So notice how when I look at this, it's a lot less than I'm having to do over here. But I can do it either way and find the right answer. Okay, factoring is factoring. This is just, if I see that I've got the difference of 2 squares, I have my x squared on one side, my number on the other, take the square root, and my answer will be plus and minus. Okay, so let's look at our examples. Let's see, I'll put these up at the top of the board. So in the classwork, I've got x squared minus 25 equals 0. What do I need to do first?
Isolate.
Isolate x squared. So I'm going to end up with x squared is equal to what?
25.
25. What is the square root of x squared?
X.
What is the square root of 25?
5.
That's it. But I have to put the plus or minus. Yes.
Wouldn't it be negative 25?
If I move this from this side to this side, notice I've had to add 25 to each side. Notice that I skipped a couple of things here. This is the minimum I should see for your work, because some things can be done in your head, but you can write everything out if you need to. If you want to add 25 to each side and write it out, write it. If you need to write the square root of x squared equals the square root of 25, write it. Okay? I'm just trying to show you that there are a couple of things that if you know the steps in the process, there's a couple of things you can do in your head and not have to write them down. Okay? Let's look at the next one. X squared minus 13 equals 0. What am I going to do first?
Isolate.
Isolate. So I have x squared is equal to 13. What should be in your mind right now? There's not a perfect square for 13. So I love horizons because they love to throw in radicals. Okay, don't you love it? So can the square root, can 13, so basically I'll just go here. Okay. There is no perfect square of 13. 13 cannot be simplified because 13 is a prime number. So the way I'm going to write this is I'm going to write x is equal to plus or minus square root of 13. I'm just going to leave it as a radical. Okay, I don't even have to worry about like trying to use a calculator and trying to find a decimal or anything like that. Just leave it as an as an imperfect square. Okay. If I have a radical that could be simplified, like in the third example, then I will. Okay, so I'm going to erase this one right here. We're going to look at example 3. All right, example 3, I have x squared minus 18 equals 0. What's my first step? Isolate. So I'm going to have x squared is equal to 18. So I'm going to take the square root of x squared is equal to the square root of 18. Now, is 18 prime?
No. I mean,
No, it is not prime. So that means I need to break it down to prime factors. Okay, so that means I'm going to have x is equal to the square root of, what is my smallest prime factor of 18? 2. And 18 is 2 times what?
3
Times 9, and 9 is 3 times 3. What can come out?
3.
Here are my buddies. So x is equal to 3 times the square root of 2, and I'm going to put my plus or minus in front of it. So if it is a radical that can be simplified, I simplify it. If it's a perfect square and it cannot be simplified, it's just going to stay exactly like it is. But the main thing here is that plus minus in my answer. Because again, it could be positive or negative underneath the radical. So we have to state both possibilities. Okay? All righty, let's go ahead and work on activities 2 on page 203. Follow your steps. Isolate, take the square root of each side, state your solutions as positive and negative. If you need help, let me know and I will come help you. What did step 3 tell me I needed to make sure? Plus or minus, good.
That's 30.
What times what makes X squared?
It can be simplified.
X is X, right?
Nothing
So the
is
square root of
really
X squared is X.
Mhm.
Okay, go ahead under here, got X. Okay. Okay, so this should be taking the square root of just 0 to 100. There we go. So now what is the square root of 100? 10. And we know that it needs to be plus and minus.
Nothing. Yeah, it's just 26.
And what is the square root of 100?
That's 3 and then 11.
Mm-hmm.
55. Yeah. So it's plus.
So we don't need that anymore. It's gone away. So, we did the square root of X squared. Go ahead and erase this one. So remember, we're going to isolate X squared, so put X squared equals. And we're going to move that negative 100. So if it moves from this side to this side, what is it going to be on this side? Good. Okay, so this is square root of X squared. Good, so I put it here. It is equal. This is square root of 100. Good, and this is where I put my plus and minus. Good. So what's this one of these? X squared equals 6.
No, wait. Divided by 8. It's 40. Okay.
Or 60.
Why do I have to do time? It's all time too. Yeah, it's fine. 57, it does.
Yeah, I know.
And you can simplify that too. I'm so excited. No, 2. 2. No. Oh, wait, that's 18. Wait, 3 does look like I'm sorry. Hold on. I'm excited. Well, right? Well, yeah. I know, but 2 times 4, 4 times 8, 8 times 2, 16, 16 times 2, 32. Okay, yeah.
What?
Yeah.
Is the square root of 1 1 or
Plus or minus.
No.
It's gonna be +1, -1.
oh
Yeah, so the square root of 1 is 1.
Well, imagine. I want to put I couldn't decide if I wanted to put a box or
I don't have one yet.
I
can see which of your square roots that you left could be simplified. What does this name have? So each one will have a plus minus. Make sure that you have plus minuses in all your answers.
First grade.
Did someone die?
Now, so let's take a look. What times what is 26? What's half of 26?
Yes.
2 and 13 are both times. I know that's a simplified. 3 times 11 is 11 times. That's a simplified. Okay. That was right. No, you're right. Yeah. So I'm just saying that these probably, okay.
It's not on my board.
41, I don't have anything to like. 41.
Okay, I'm gonna watch another.
57, nothing.
I know. I was the trend. I was like,
Oh. 3 and 4. Which of those could be
is
broken
it
down?
good?
into
I heard
numbers?
it's like kind of slow.
And so you would have what times what?
Okay.
Good. What come out? Remember, these two come out right here.
Yeah.
Okay, so all you have left is that 3. So now those two come together, and then that one is 3.
I know. I saw that the other day.
What times what?
I'm trying to remember which one it is. Is it the one?
Yeah. So the bottom row, you're gonna have simplified radicals. The bottom row, you should be able to simplify each of your radicals. They should not just be left as the square root of the number. Look to see what can be simplified. Check to see, did you simplify radicals in the bottom row? What times what is 27?
3 times 9.
3 times 9, good. Yes. Sure. Yeah, while everybody's finishing up, if you want to go ahead and get started on your homework, you can.
Is the rest of class homework? Or are we doing something else? Is the rest of class homework?
I'm not sure just yet. So if you notice that your first row should be numbers, your middle row should all be imperfect squares, and then your bottom row should be simplified radicals. Okay, so you can kind of see, so you can look and see if you didn't follow that pattern. The top row should be just numbers, plus or minus numbers. The middle row should be plus or minus radicals. And then the bottom should be plus or minus simplified radicals. Give y'all a few more minutes to finish up. Okay, opposite signs. Think about what are all your factors of 12. 1 times, 2 times, 3 times. This is where knowing your times tables really comes in handy. If you still struggle some with your times tables, when you're looking at these numbers, if you know times tables and you go, hey, 7 times 8 is 56, so I know that I don't have anything that equals 57. Same thing with 27. Hey, I know that's 3 times 9. Or 32, 8 times 4. So thinking about if you know your times tables, that helps you when you're being able to do these. I know that 26 is nothing but 2 times 13. Both of those are prime, nothing I can do. Okay, so let's go ahead and start checking these. So on this one, I would end up with x squared equals 100. So x is equal to plus or minus 10. Number 2, x squared is equal to 9. So x is equal to plus or minus 3. Number 3, I have x squared equals 1. So x is equal to plus or minus 1. Number 4, x squared minus 49. X is equal to 49. So x is equal to plus or minus 7. Okay, so the first one, plus or minus 10. Next one, plus or minus 3. Plus or minus 1. Plus or minus 7. Any questions on the top row? Let's look at the next row. I'm going to have x squared is equal to 26. What do I know about 26?
It's not a perfect square.
It's not a perfect square. I mean, it is. I know that 26 is going to be 2 times 13. And so I know that neither of those can be simplified. So I'm going to leave it as x is equal to plus or minus the square root of 26. The next one, x is equal to, or x squared is equal to 33. So x is equal to plus or minus the square root of 33. Number 7, x is equal to 41. Sorry, x squared is equal to 41. So x is equal to plus or minus the square root of 41. And then the last one, x squared is equal to 57. So x is equal to plus or minus the square root of 57. Any questions on those? All right, last row. X squared is equal to 12. So x is equal to plus or minus what?
2 times 2 is 3.
2 times the square root of 3. Okay, because 2 times 2 is 4, 4 times 3 is 12. So when I simplify, my 2 comes out, my 3 is left under the radical. Number 10, x squared is equal to 27. So x is equal to plus or minus
3 times square root of 3.
3 times the square root of 3. 27 is 3 times 3 times 3. So my 2 buddies come out. So I have a 3 that comes out, a 3 that has to stay under the radical. 11, x squared is equal to 32. X is equal to plus or minus 4 times the square root of 2. We said that 32 is 8 times 4. And so I've got 4, I know is 2 times 2. And then 8 is 2 times 4, which is also 2 times 2. So when I simplify, I end up with 4 times the square root of 2. Any questions on that one? Number 12, x squared is equal to 50. So x is equal to plus or minus 5 times the square root of 2. So thinking back on those rules on how I simplify radicals. Okay. Any questions on any of those? Now remember, if you were just to remember the steps from lesson 91, I could still solve using the regular way for factoring. But if I look at it and I can see that, hey, I've got the difference of 2 squares, then I can just set them equal to each other and have a plus or minus, whatever, whole number, simplified radical, or imperfect square. Any questions on that? All righty. What I want to go ahead and do, let's see, we've got about 15 minutes. Let's go ahead and take the notes for Thursday, okay? I'm not going to teach the lesson for Thursday, but let's go ahead and take the notes for Thursday so we'll have that part of it done. And then once we finish taking the notes, then you can work on this homework assignment. This will be your only homework assignment due Thursday, okay? So I'm going to go ahead and erase the board, and we're going to do lesson 93. Notes. So go back to your note paper where you've taken lesson 90, 91, and 92 notes. Right. So this will be lesson 93. Solving quadratic equations by completing the square. By completing the square. So we've got some similarities here because in the last example, we were factoring the difference of two squares. So here I've got the common word square, but the other one was factoring the difference of two squares, and now this one is completing the square. So it's going to be, we kind of have some similar terminology, but this one actually just has steps in a process that we just have to go through these steps, okay? Because if you don't, then you can get totally hung up and go, I don't know where I go next. So let's go ahead and write out these steps. And like I said, we will actually start learning this on Thursday. So it says a second way to solve quadratic equations is completing the square. This method uses the same principles you used to take roots in lesson 92, but with quadratic equations in the form of x squared plus bx plus c equals 0 rather than x squared plus c equals 0. So it says to complete the square, follow these steps. So here are our steps. Step 1 is to isolate c on one side of equal sign. So just like we did a minute ago, how we had to isolate x squared, this time we're going to isolate c. Okay, so basically if I have x squared plus bx plus c equals 0, I'm going to subtract c from each side, and I will have x squared plus bx equals negative c. Is everybody with me so far? C was over here. I want to isolate it. I want it by itself on the other side. If it's positive, I subtract it. If it's negative, I'll add it. Okay, so it just depends on if it's positive or negative will determine whether I add or subtract it. So that's step 1. Step 2 says I need to add the value of b divided by 2 squared to both sides. I know right now you're probably going, what in the whole wide world does that mean?
I know that.
Good. Awesome. You can come teach it now. Okay, so we want to add the value of, this is read as b divided by 2 squared to both sides. Okay. So we're not even going to write the rest of that, because if you look at the rest of that statement, it says this creates the perfect square trinomial in the form of x squared plus or minus 2xy plus y squared, where c equals y squared. What? Don't even worry about that right now, okay? We're just saying b divided by 2 squared. So let's pretend, everybody ready to play let's pretend? Let's pretend that b equals 6. If b is 6, what is 6 divided by 2? 3. What is 3 squared? 9. So I would add the value, I would add 9 to both sides. Does that make sense? So whatever b is in my equation, whatever b is right here is where I put it right here. Whatever that number right there is, I'm going to divide it by 2. And then whatever that answer is, I square it. Yeah, so I'm creating a perfect square. Okay, so instead of like breaking down a perfect square into factors, now I'm making a perfect square. So I take that number, divide by 2 and square it, and then I add whatever that number is to both sides. Okay, so now my next step, step 3, is to take the square root of each side. And I'm going to make a little asterisk here that says, remember, plus, minus. Okay, so one of the things to always remember is that I need to make sure I give the positive and negative options, because whenever I take the square root of a number, it could be positive, it could be negative. So I have to do the plus minus. And then step 4 says, solve for x. Solve for x using both plus and minus values. Okay. So step 1, isolate C on one side of the equal sign. If it's positive, I'll subtract it to move it. If it's negative, I'm going to add it to move it. Okay. So I isolate C, step 1. Step 2, add the value of B divided by 2 squared to both sides. We just talked about where I find this number here is in my equation from step 1. Whatever this number is here, I divide it by 2 and then square it. Whatever that answer is, I'm going to add to each side. Then I take the square root of each side, remembering that when I take square roots, I have positives and negatives. And then I'm going to solve for each positive and negative term. Right now, again, I don't expect it to make sense, but at least we've got this written down. So on Thursday, when we come in after we've checked our homework, and I come around and I look at everybody's homework and I say, great, everybody's made 100 on the effort part. And then we check it and go over answers. And then I take it up and I grade it and go, great, everybody made 100 on the accuracy part. I won't grade it during class. But then after I've taken it up, I'm going to say, get out your notes on quadratic equations. And you'll get out your notes and we're going to review the lesson 93 notes. And then we're going to actually practice it. Okay. I know. It's amazing, isn't it? So Thursday is our second class of 5 weeks left until we get out of school. Okay. So on Thursday, we will be working with completing the square, and then we will finish up with solving using the quadratic formula. So we'll do both of those on Thursday. The next Monday, we will learn about the discriminant. We will review all of these, and then you will have a take-home open book test on quadratic equations. Okay, so not this Thursday, but next Thursday, you will have a test on quadratics. Then we will start our new unit. Our next unit will probably be on, I'm thinking about doing word problems next. Oh, it's going to be just fine. It'll be just fine. So we'll do word problems next. Okay. All right. It is 11:58. We have 7 minutes before the bell rings. Okay. So if you have questions, let me know. If you're working on homework, that is fantastic. Let me know. Zoe, if you have questions or need anything, be sure to let me know, but I'll get ready to log off, okay? Yes. Okay. So remember, this was the one where I'm going to be doing box method. Okay, so remember I said if you have a number here other than 1, I'm going to set up my box method. Okay, so go ahead and draw your box real quick. Remember on your homework that I told you that if you have a number that is larger than